Hi everyone, welcome to Pre-Calculus Lesson 8.1. In this video we're going to talk about polar coordinates, specifically how to change between rectangular coordinates and polar coordinates. So how to change an r theta into an xy, how to change an xy into an r theta. So what I have here is I've graphed a point and I've written its ordered pair in two different ways. Now let's think about what this means in terms of x and y. What this means is that I've gone x units in this direction and y units in this direction. Okay, and this makes a right triangle. So let's think about how to find this distance on this side. We would use the Pythagorean theorem. So x squared plus y squared equals this squared. And we're going to call this the r squared. And if I wanted to solve for r, I would find that r squared equals x squared plus y squared. I could also solve for r to get that r equals the square root of x squared plus y squared. So I could write it this way, or I can write it this way. Now, what if I wanted to describe this angle here? We would use trigonometry. This angle is theta, and I want to write it in terms of x and y. So theta, we have an opposite and we have adjacent, so that's going to be tangent. So tangent theta equals y over x, opposite over adjacent. Okay, now these are the two formulas we're going to use to find r and theta if we have our rectangular coordinates. So if you're given rectangular, the normal kind, and we want to change it to polar, these are our two equations. You're going to take the x and the y and you're going to plug it in this and solve for r, or you're going to take the x and the y in here and use inverse tangent to solve for theta. So that's our first set of equations. Now for our next set, let's also look at this, and we have theta here again, and we have y and r. So this is opposite and hypotenuse. So that's sine theta equals opposite over hypotenuse. And what I can do is I can solve this for y, and that will give me a y value. I can just change this into r sine theta is going to be my y value. So if I know r and theta, I can figure out what y is going to be. Now for cosine, I have adjacent and hypotenuse. So it's going to be cosine theta equals the adjacent over the hypotenuse. And I can go ahead and solve for x and find out an expression for x. Now, the beautiful thing about this is you may recall from our unit circle lessons that x is cosine and y is sine. So that helps you remember these. But these two formulas are the formulas we're going to be using if I am given polar and I want rectangular. So let's try some questions, and I'll show you how to change between formats. So perhaps I have the point 4 and 2 pi over 3. Okay, I'm going from polar, because this is an angle measure, to rectangular. And normally they'll say go from polar to rectangular. So if you're not sure, usually it's given in the directions. So polar to rectangular, I'm going to use this set of equations here. So I'm just going to plug in what I know. I know r is 4 and sine theta, sine 2 pi over 3. So for this, I would get out my unit circle and I would find out the sine at 2 pi over 3. Now remember, this is the y value. 2 pi over 3 is square root 2 over 2. And, square root 3 over 2. And I would do 4 times this. And then I can just reduce, and I get 2 square root 3. And that is the y value. It is the exact y value that I need. Now for the x value, I'm going to do r cosine theta x is r, so 4, times the cosine of 2 pi over 3. Cosine at 2 pi over 3 is negative 1/2. And I have to multiply that times 4. So x is going to be negative 2. Now I can just write this as an ordered pair. So negative 2, 2 square root 3. So this graphed, and I would just get a decimal number for this y value, would graph to the same point as that. Okay, let me show you an example going in the other direction. This time I'm going to give you a rectangular coordinate, and we're going to change it into polar form. Okay, so polar form from this rectangular one, and I have the point 2, negative 2. So I have rectangular, and I'm going to polar. So that's this one right here. So I'm going to do r squared equals x squared, so 2 squared, plus y squared, negative 2 squared. Now I just need to solve this for r. This is going to be 4 plus 4, and the square root of that. So 4 plus 4 is 8. So r is the square root of 8, which is 2 times the square root of 2. And I just simplified that. Remember, we do factor trees. We look for pairs. You cross one out, and one goes to the outside. And then this has to stay on the inside because it doesn't have a pair. Okay, so that's my r value. Now for my theta, I'm going to write tangent theta equals, and remember, tangent is y over x. So negative 2 over 2. So tangent theta is negative 1. Now we have to be careful about this because there are actually 2 places on the full unit circle where tangent can be negative 1. And that's going to be at 3 pi over 4, or it's going to be in fourth quadrant, which is 7 pi over 4. And the way we choose between these is I look at where this is going to graph. It's positive 2, 1, 2, negative 2. That's a fourth quadrant point. So I'm going to pick the fourth quadrant angle. And graphing it can always help. So I have an r and I have a theta. So I'm going to write 2 square root 2 and 7 pi over 4. And that's my answer. Now, if you wanted to, instead of writing 7 pi over 4, you could write negative pi over 4 because technically when we do inverse tangent on both sides, it can only give a first quadrant or a negative fourth quadrant angle. So I would get negative pi over 4. So technically that would be correct. This is just an alternate way of writing it. So you could have given this because technically inverse tangent would work for this one. But 7 pi over 4 is equivalent. Okay, so that's it for this video. Make sure to watch the next video about converting equations between the two formats.